right, at this point, the days may be getting off from the plan a little bit, but this is the day 7 sequence and series unit video. And I believe most of this from our review for Benchmark 3 you will remember, but questions 3 and 4 we did not do a whole lot in, even in that review. So you're definitely going to want to pay attention to those because you haven't seen them in a while, but the rest may be pretty familiar to you. But again, it's all for question 12 on the constructive response, which has a lot of layers to it. It has arithmetic, geometric, sequence, and series all built into one question. So here we go. Number one. Um, just a quick reminder, the formulas that you have available to you on the yellow sheet are, sequence for arithmetic, sequence for geometric, and then sum, which is called series for arithmetic, and sum for a geometric, which again is called series. We'll be using those in the first problems. Whether or not you remember, sorry, wrong file, whether or not you remember the formulas and whether you need to use them or not is not the important part of this review. I want to make sure you remember them because you do need them on question 12 because you have to show your work with those formulas. So arithmetic, first year of the tuition is $4,000. It increases $600 each year for 10 years. What will it be in the 10th year? While you could list them out, let's force ourselves to use, and since it's a list, it's a sequence, let's force ourselves to use the formula a sub n equals a sub 1 plus n minus 1 times d, which would be a sub n, a sub 10 equals a sub 1. The first term is 4,000 plus n minus 1, so that would be 10 minus 1 times the d, which is the thing you're adding each year, 600. The formula would say that equals 4,000 plus 10 minus 1, 9 times 600, so 4,000 plus 5,400, you get the answer C. I'm going to skip down now to question 2 while it's fresh on our mind and continue question 1 to ask a somewhat unnecessary question, but to illustrate the sum formula. Find the total amount a student would have had to have paid if he or she began in year 1 above and stayed in college for 10 years. So what's that asking? It's asking for you to take the first year 4,000, the next year 4,600, etc., all the way to the last year 9,400 and add them up. It's asking for a sum, which is a series, so we'll be using this formula. S sub n equals n divided by 2 times parentheses first term plus last term. So with symbols, that'll look like S sub n equals, I'm going to change that in, sorry, S sub 10 equals 10 divided by 2 times first plus 10th. And we've got the first term, 4,000. We found the 10th term, 9,400. So it will equal 10 divided by 2 times 4,000 plus 9,400, which is 5 times 13,400, which gives you 67,000. That's the arithmetic sequence, the arithmetic series formula in action. So we're going to switch gears now to geometric in number 2 and find a sequence answer and then a series answer. So essentially reviewing all 4 formulas. So geometric, advisor tells me that financial consultant has a $43,000 salary for the year, a sub 1, 43,000, and gets a 3% increase on the salary each year. So here, that by 43,000 by 3%, 0.03, and adding it back. You'll remember, multiply it by 103%, 1.03, and you'll get the second year immediately. If you're going to add 3% each year to the original 100%, it's the same as multiplying 43,000 times 0.03 and adding that to 43,000 if you would have just typed 43,000 times 1.03. So in other words, your R is 1.03 because this is a geometric pattern. If Ming takes a job as a financial consultant, what will her salary be in the 35th year? Again, I'm using the formula a sub n, a sub 1 times r to the n minus 1. I'm using the sequence formula. It's not asking us to add her salary each year yet. It's asking us to find the 35th salary. So take the calculator and take your first year, 43,000, times the R, which is 1.03, to the 35 minus 1. Her 35th year will be 43,000 times 1.03 to the exponent 34, making 115,471.92. See. And then we're going to piggyback right off that question. Use the amount of money with to employment. So what that means is take her first year, 43,000, plus her second year, which we still have on the calculator here, 44,290, plus her third, plus her fourth, all the way to her fifth year. So yes, you could find this by punching in her second year times 1.03 to get the third year, times 1.03 to get the fourth, and so forth. But for the sake of the constructive response, you're going to have to work with the formula. So let's do that. We're going to use the series formula, S sub n equals a sub 1 minus a sub 1 r, all divided by 1 minus r. That's a mouthful, but S sub n equals a sub 1 minus a sub 1 r to the n over 1 minus r into this. S sub 5, adding the first 5 of the first year, 43,000, minus the first year, 43,000, times the r, which was 1.03, raised to the n, so we've already declared n as 5, and divide that by 1 minus r. That's the shortcut, if you will, finding the sum of those first 5 years. Be careful with the calculator. I'm going to model it for you. 43,000 minus 43,000. This is the way most people will start to type this. So I'm modeling that for you. And when you hit exponent 5, if you choose to now hit the divided by arrow, you're going to miss this problem because you didn't start with a parentheses. You have to hit enter now. You didn't start with a parentheses right there. You have to end one there, divided by, remember the calculator, it follows its order of operations, and you have to group that whole top with parentheses, and I didn't do that, so I need to just hit enter, and then divide it by 1 minus. You can type that, and if that's what you want to do, you want to type that, then you got to open a parentheses, 1 minus 1.03, and close it. If you don't, you'll still miss this question. I personally wouldn't do that. Personally, I would just do a little mental math. What is 1 minus 1.03? Negative 0.03. But either way, you get the answer. 228,000. So that reviewed 4 formulas. Arithmetic formula, the arithmetic sum formula, the geometric formula, and the geometric series formula. There's more videos that the substitute teacher probably will have for you that using in another class goes into sequence and series more in depth. If you feel like you need to watch some of those or pieces of those, I'm sure they would be glad to show you those. Now let's look back at the other 2 problems here. We don't need to do question 5. We've covered that. But we probably need to address sigma, and then that'll be the end of the video. Sigma, if you'll remember, means sum. That's the letter sigma, and it means add up these terms. The one that's at the bottom tells you start with 1. So plug in 7 minus 2 times 1, and you get 5. Then plug in 2. X equals 2. 7 minus 2 times 2, and you get 7 minus 4, you get 3. Plug in x equals 3, then 4, then 5. Plug in all the way to x equals 10. So all the way to 7 minus 2 times 10, which would be 7 minus 20, negative 13. And according to sigma, add all numbers. So you could literally just keep plugging them in. I plugged in x equals 1, x equals 2, plug in x equals 3, 4, 5, etc., all the way to 10. But what will happen is you'll start to notice a pattern. When I plugged in 1 and I plugged in 2, I got 5, then 3. When you plug in x value 3, 7 minus 6, you get 1. When you plug in 7 minus 2 times 4, 7 minus 8, you get negative 1. You'll notice you're subtracting 2 each time. So after negative 1 will be negative 3, then negative 5, then negative 7, then negative 9, then negative 11, and then negative 13, which is the last one we already knew to stop there. So you add those up, 5 plus 3 plus 1 plus negative 1, well, the negative 1's cancel, the 3's cancel, the 5's cancel, you get that answer. Negative 20 plus negative 20, negative 40. Answer C. All right, that's enough for the sequences and series. Again, there are other videos out there if you feel like you need to see more.